Algebra 2, Chapter 13.2, exercises 11 through 16. This section has to do with graphing exponential functions. These instructions here for 11 through 16 are: state the domain and range of the given function and identify the new values of the reference points and the asymptote. Use these values to graph the function. I'm going to start out with domain and range, and for this exponential function and any exponential function, our domain is going to be all real numbers, which I'm going to put in interval notation as greater than negative infinity, comma, less than infinity. So that's going to be our domain. Now for our range, if a is greater than 0, in this case it's 2, our range is going to be greater than k up to less than infinity. And here in this situation we have k is equal to -1. So what we're going to have here is our domain is going to be greater than -1 to less than infinity. And this also determines for us where our and what our horizontal asymptote is. The horizontal asymptote, I'm going to write this over the right, horizontal asymptote is going to be the equation y is equal to k or -1. So I'm going to draw a horizontal line, dashed horizontal line here at y equals -1. So y equals -1. And then what else? Okay, our parent function here is going to be, I'm just going to put parent function is going to be f of x equals 2, our base is 3 to the power of x, which means for our reference points we're going to have input values, so I put x, f of x, input values of 0, which will determine our y-intercept, and 1. And so if we put input value of 0, 3 to the 0 power is 1, and then for an input of 1, 3 to the first power is 3. So these two sets of coordinate pairs, 0, 1 and 1, 3, are the reference points that we are going to transform to determine and graph this function. And so I'm going to start over here to the left and put these points here. We're just going to go to the right. I have 0, 1, and right below it 1, 3. And then we're going to go to the right here, and the first things that I'm going to do is translate these functions. So in this case we have, for x plus 2, we have h is equal to -2. And why is that? Because if we have x minus -2, that ends up being x plus 2. So what we are going to do is shift 2 units to the left. So I'm going to put here translate 2 to left. And what that's going to do is it's going to change this 0, 1 to -2, 1, and this 1, 3 becomes -1, 3. So we have shifted or translated these reference points 2 units to the left. the next thing we have is k is equal to -1. And so what that is going to do, I'm going to write this down here. I'll put your translate 1 down for 1 unit down. And so what we have here is we bring over this already translated reference point, and -2, 1 moved 1 down is going to be -2, 0, because 1 minus 1 is 0. And this next reference point is going to be -1, and 3 minus 1 is going to be 2. And what I'm going to do now is just plot these twice translated reference points here on the graph. And to do that, I'm going to do that in red. So what we have here is -2, 0. So I put -2, 0 right here. And then we have -1, 2. So -1, 2. Okay, and the last thing we're going to do here is we have a is equal to 2. Whatever, I'm going to arrow this right over here. So I'm going to put a is equal to 2. Well, this is our factor of by which we vertically stretch this function. So I'm going to put vertically stretch by a factor of 2. I'm going to just put by 2. And what we do for that, our input values remain the same. So we have -2 here for this first reference point and -1 for the second one. And so we go back over to the graph, and this first reference point at x equals -2 lies 1 unit above the horizontal asymptote of y equals -1. And stretching by a factor of 2, we need to find ourselves twice the distance. So we are up 1 unit, we need to go up here another unit, which is twice as far from the horizontal asymptote. So what we have here is the point -2, 1. So that goes right there. That is the translated point. And for the second reference point, we have -1, 2, and we find ourselves 3 units away from the horizontal asymptote. Where we need to be is twice that distance because of that factor of 2, and 3 times 2 is 6. So we need to go up 6 from the horizontal asymptote, or the point -1, 5. And so I put -1, 5 right up here, and then it says use these values to graph the function. And what we have here is this. Okay, and I'm going to try to get this right. So -2 is going to be something like this. Okay, we're going to be 1/3. Yeah. So the graph is going to look like this. Okay. So there we are. That's the graph of the function. You can verify using a graphing calculator. So that's it. Okay, next odd number problem, which is number 13. We have the function fx equals 3 times 6 to the power of x minus 7 minus 8. Let's see if they're asking for the y-intercept, because that was... No, they don't show that there. So let's go here. Our parent function for this is going to be f of x equals 6 to the power of x. And so our reference points for input, we have x, f of x, are going to be 0, 1, and 1, 6. So the horizontal asymptote is going to be k. So here we have k equals -8. So we put right here at -8. Okay, we have a horizontal asymptote y equals -8. That is right there. And then what we have here is, okay, we already know that, and h is going to be equal to, we have -7, so h is equal to 7. Okay, and then a is equal to 3. So we have similar to problem number 11. So let's go ahead and do that. Let's talk about domain and range first. I'm going to write this over here. The right domain is going to be all real numbers, greater than infinity, less than infinity. Our range is going to be greater than k, which is -8, but less than pos infinity. So that's our domain and range. Okay, now we have our points that we're going to transform. So let's go ahead and put these over here to the left. We put 0, 1, and then 1, 6. So the first thing we're going to do is translate this. We'll say 7 units to the right. So we have, I'll put up here, translate 7 units to the right. So that's going to be, in order to do that, we're going to add 7 to the x value. So 0 plus 7 is 7. So we translated this 7 units to the right. And then 1 plus 7 is 8. Okay, the next thing we're going to do is translate by k, and k being -8, we're going to translate 8 units down. I'll just put translate 8 down, representing 8 units down. And so what we're going to do next is take that y value and subtract 7 from it. Let's see. Oops, for this stuff we had y 8, 6. There we go. Okay, that looks better now. Okay, we're going to subtract. So 1, we're going to keep our x value, 7, and 1 minus 8 is going to be -7. And for the next one, 6 minus 8 is going to be -2. Okay. And so that's going to be, what I'm going to do right now is mark those twice translated points. So for the first one we have 7, -7. So these grids are by 2. So 7, -7 is going to be about right here. And then we have 8, -2. So we go 8 to the right and down 2. And finally, we have stretch by a factor of 3. So we'll call it vertical stretch by factor of 3. Put factor of 3. And so we see where they are marked. And so for the first reference point, 7, -7, we are 1 unit above the horizontal asymptote. So we need to go ahead and multiply that by 3. So let's multiply by 1, multiplied by 3, by 2, by 3. So what we're going to get here is the coordinate pair 7, -5. And then for this other reference point, which is 8, -2, we are 6 above -2 minus -8. We are 6 above the horizontal asymptote. So we need to be 6 times 3 or 18 units above. So we can just count by 2 up here. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So here we are. So what that's going to look like is this right here. Straight up like that. That's about as good as I can, as well as I can make it. So let me mark that as 8, 10. So that's going to be it. We have our domain and range, and we have transformed the points, used our horizontal asymptote in graphing. Okay, the next one we're going to do is problem 15. Okay, so we have h of x equals -1/4 times 5 to the power of x plus 1 minus 3/4. So in this instance we have k is equal to -3/4. We have h, we have 5 to the power of x plus 1, so h is going to be equal to -1. And we have a is equal to -1/4. And our, let's go ahead and draw in our horizontal asymptote. So we have k equals -3/4, and I'll write this in here. It's going to be about here. So k is equal to -3/4. So there that is. That's our horizontal asymptote. And then, as far as our parent function goes, our parent function is going to be, we'll call this f of x equals 5 to the power of x. And so for x, f of x, in our parent function, we're going to have 0, 1 and 1, 5. Okay. What next? Our domain. Let me write our domain. Domain is going to be, I'll put this below here, greater than -infinity, less than infinity. And our range, well, what's happening is a is negative, so what we're going to have is we're going to be greater than -infinity up to less than k. In this case, k is -3/4, so I'm going to change that with, substitute in -3/4 for k. And so that becomes our range. Okay, and we're going to be doing now our translations of our transformations of our reference points. So we're going to have, in this case, 4 of them to do. And we're going to do these in the order that's going to make the most sense as far as being able to graph these. So I'm going to write these in as 0, 1, and right below it 1, 5. Well, the first thing we have is we have a negative number here. So what we're going to do is reflect about the x-axis. I'm going to put down here reflect there it is. Reflect about x-axis. And what do we do for that? What's going to happen to reflect about the x-axis? We're going to take that value of 1 and multiply it by -1. So we get 0, -1. And for the second reference point, we take that value of 5 and make that a -5. So that's going to be our first transformation. Next, we're going to take this h equals -1, so that's going to shift, or I'm going to say instead translate 1 unit to the left. Alright, so that's going to be, what we do is we take that 0, that first x value of 0, and we subtract 1, so we get -1, -1. For the second one, we take 1 minus 1, or 0, so we get 0, -5. Okay, the next thing we're going to do is we're going to translate down 3/4 of a unit. So translate 3/4 of a unit down. So what we have here is we keep the x values in place and we subtract 3/4 from these values right here. So we have -1 minus 3/4 is going to be -1 and 3/4, or I'll put -1.75. Okay, that's going to be that one. And -5 shifted down 3/4 is going to be -5.75. Okay, so now I'm going to mark these points here. So we have -1, comma, -1.75. So there we are. And then we have 0, comma, -5.75. So these go by 1. So -5 is the lowest value we see. So we're going to take it down here a little bit below. So there we have it. And the last thing we're going to do is we're going to vertically compress by a factor of 1/4. So let's do that. So vertically compress by a factor of 1/4. So I just put 1/4. So what we're going to do is take 1/4 of the distance to the horizontal asymptote. Well, here for this first point I'm going to put the x values in place, leave them the same. So we are 1.75 or negative 1.75, which is 1 full unit below the horizontal asymptote. And so what we're going to have is that 1 divided by 4, which means we're going to come 1/4 of that distance is going to be right here where y equals negative 1. That's going to be 1/4 of the distance. And finally for this one, 5.75, we are going to be 5. How far are we below here? 1, 2, 3, 4, 5 units below. So we're going to have is 5/4 of that distance. Well, that's going to be 5. So 5 divide, so we'll have 5/4 of this distance. So 5/4 of 1, 2, 3, 4, 5. That's going to be 5 off 5.75. So 5/4. So we're going to have negative 3/4, which is the value of our horizontal asymptote, minus 5/4. And so we're going to get is negative 8/4, or negative 2. So we have our point 0, comma, negative 2 right here like this. Okay, I had this in the wrong place. Yeah, this thing is going to be right here. Yeah, 0, comma, negative, it's right here. So we're going to have is this right here, very compressed. It's going to go way down like this. So that's it. So really that's it. I want you to just look at number 16 briefly. What we have here for number 16 is the parent function is going to be f of x equals 4 to the power of x. And we'll do similarly like we did with problems 11, 13, and 15. I hope this has been helpful to you. Good luck, and thanks for viewing.